Okay, welcome Joy, and welcome Ozzy, and welcome Tammy. Thanks for coming. Today we're going to be talking about chapter 8, which is all about confidence intervals. It turns out that this is one of the big weeks of absolutely being really useful for real life, like being able to read a news article and understanding whether they did their job, what does it mean, how far off are they, and then of course, how do you do your own research and do things right? And that's kind of what's going on today. I don't think it's necessarily the hardest topic. It's not easy, but it's not the hardest. The good news is that we don't have any major assignments to talk about today. So in fact, if you look at the syllabus, then you'll notice that the next big thing that comes up is what's our next big thing? Yeah, the midterm, as Joyce said. So the midterm is the next big thing that's coming up. Just to let you know, that's February 27th. So it's time to start thinking about it. You will also notice that there is an assignment before then. And in fact, let me grab that. It asks you basically where you're going to take it and when are you going to take it. So that is absolutely necessary, because if I don't know where you're taking your midterm, then you're not going to get a midterm and you get a 0, and that's really bad. So this is one of those crucial assignments where you have to do it. There's no plan B on that one. So you do need to let me know, and that is due on the 20th. You can do it earlier, that's fine. And that allows me to take a look and find out where and who do I send it to. When you're looking for your proctor, the requirements I have is it needs to be an established proctor. So if the two most common established proctors are a college and a public library. Those are the two biggies. The third most common probably is a tutoring center. Okay, they tend to be a little more expensive, but that they also will do proctoring. Okay, and then there's others too. If you let me know where you live, if you're having troubles, I can, or what city you live in, I don't need to know your address, but just the city you live in, then I can give you some ideas on places that would proctor your midterm nearby where you live, if you want to do that, or nearby where you're going to be. It doesn't have to be where you live. So just to note, that's kind of the next upcoming major thing that's happening in the class is the midterm. There's already stuff for the midterm, but it's a little too early to start talking about it because, again, the midterm isn't for a few more weeks. So 2 weeks from Wednesday. Unlike other things, this one's due Wednesday because most people need to go to a public facility, and public facilities are closed on Sunday night. So I don't have it due Sunday night because that would be a disaster for a lot of you. So are there any questions about anything that you've been going through or doing some statistics or something about the class? This is a good time to ask. Any questions? Okay, just a note, I've started looking at your projects. I'm about a third of the way done reading the projects. I figure hopefully by Wednesday I'll be done reading them. I did your regular old discussion forum assignment first. That way I could get it over with and then focus on your projects. But they take a while. It's not like just reading the little 2-sentence thing and writing some comments. I have to read the whole project and look to see what you've done and where you could have improved on. So again, you can take a look. One of the things about the project, because your group had only one person submit it, that only shows up in one place in the gradebook, and that's that person's submission. So I put in comments directly on your paper that the person who submitted it can see. So please share the comments I put on with your partners so they know where things went right and where things went wrong on the project. Okay, be nice to each other. Any questions before we start? Okay, so what we want to do now is I want to give you a news article. Okay, I'm going to do a Gallup one. Gallup tends to have information that we can use in this class really easily. Other articles do too, but Gallup is the easiest one to grab for me. So let me do a little share. Joy asked, are we going to have a review before the midterm to prepare? And the answer is yes. Yeah, we'll do a review probably next week, and at the webinar next week. Next week webinar will almost certainly be on Tuesday because I like to honor the holiday, and a week from today is the President's Day holiday. So it'll probably be on Tuesday unless I hear differently from y'all, but Tuesday tends to work. So hopefully that's okay. And we'll talk about, of course, the next chapter, which will be chapter 9. And we'll also talk about the midterm. Okay? And we'll probably talk more about it the following week, but especially next week. Because 2 weeks from now, let's see, today is the 11th, 2 weeks from now, it will be too late for a lot of you because you'll have already taken it. And if you've already taken the midterm, it doesn't help if I tell you how to prepare. So that's why next week is a week when I talk about how to prepare. So hopefully, Joy, that helps you out. If you want to look early, you can go to the module for the midterm, which is the week 8 module, and you'll see stuff about the midterm. But again, we have to do this week and next week's material before we truly understand it. Okay, other questions? Okay, so what I have is I have an article. And the article says, Americans' confidence in their finances keep growing. Okay, so that's a good thing. I'm going to look, I'm not going to read the whole article for you, but 69%, this is number one highlight, expect our financial situation to improve over the next year. Okay, do they know that 69% of all Americans, maybe American adults, expect their financial situation to improve over the next year? Do they know that? What do you think? Because that's what they say. 69% expect their financial situation to improve over the next year. Okay? And the answer is no. So even though you said no, yes, it's actually no. And how do I know for sure? And my guess is all of you know too, but how do I know for sure that they don't know the exact percent of all Americans? Okay. Yeah, they didn't talk to all Americans. I know they didn't because they didn't ask me. And I've never had anyone say yes to one of these, but did they ask any of you? Yeah, it's always a no. Okay, they didn't ask most Americans. There's 320 or so million Americans, and there's no way they can ask them all. And even if you realize that we're not talking about children, that might be 280 million Americans. Again, way too many to ask. So they don't know. So now the question is, do you think 69% is a pretty good estimate? Do you think it is extremely unlikely that it might be, say, 40%? Or maybe 90%? And that's what we're going to be talking about today. So I'm going to scroll down to the bottom. And it's something that we've been ignoring all along, and now it's time to look at it. And that is some of the details of the survey methods. So the first part we do understand. Results for this Gallup poll are based on telephone interviews conducted early January with a random sample of 1,017 adults. So again, it's 1,017 out of the 280 or so million adults in America. Is that enough? Okay. So the answer is no, according to Joy. but actually it's enough. It's not enough to know it's exactly 69%, but we can probably get pretty close. We can probably say it's pretty close. So we're going to read a little more. Okay. Yeah, it's definitely more than 30. 30 actually doesn't make any help at all, Tammy. Why is 30 the exact wrong statement to use here? No, it's not representative. It has to do with the survey question. And the survey question is are your finances going to improve next year, basically, right? And that's a yes/no question. And with yes/no questions, we're not talking about 30 anymore. Yeah, we're talking about NP and NQ have to be bigger than 5. Remember that? Okay. So NP and NQ have to be bigger than 5 because that was part of the central limit theorem. And in fact, most of you, when you did your discussion posts and discussion replies last week, you did NP and NQ greater than 5 correctly, which was good. Don't use 30 if it's a yes/no question. Any questions on that? And I will guarantee, I will give you the opportunity on the midterm to demonstrate that you remember not to use 30 for a yes/no question. Okay? And the question is, are you going to remember? And usually about 35% don't. So I'm warning you now, you need to remember that. It's a very important piece of this class, is that you always want to look at the survey question. If it's yes or no, it's NP, NQ greater than 5. It's not that the sample size has to be bigger than 30. Okay, so in particular, if you take 1,017 times the 69%, that's definitely more than 5. And if you take 1,017 times 1 minus that, which is 31%, well, 31% of 1,017 is much bigger than 5 also. It's over 300. Okay? So what that tells you is not that it's necessarily a big enough survey to like have a really good result. It just tells you that we can use the central limit theorem. It tells us that we can do some calculations with the normal distribution. Any questions on that? Having a good enough result, that's different. The first thing is, and we learned this from the first week class, is you have to make sure that you have an unbiased sample. Because if you have a biased sample, basically you don't have anything good. Okay, and then second is we want a result that actually is very meaningful. So now let me read the bit more, the important thing for this particular chapter, and that's right here. For results based on the total sample of national adults, the margin of sampling error is plus or minus 4 percentage points at the 95% confidence level. So the whole point of this hour is to explain that. Any questions on this idea? Okay, so one of the things that tells you is that they had an estimate of 69% of all Americans. That's what they're hoping. The 69% is not all Americans. The 69% was their sample. Any questions on that? Now, the central limit theorem tells you that the sample is an unbiased estimator for the population when it's a proportion. So the 69% is definitely the best guess. But now there's more to it. There's 4%. That tells you how far off you are likely to be less than that amount off. Okay? So if you go down 4% from 69%, that is 65%. 69 minus 4 is 65. And 69 plus 4 is 73. Any questions on that little calculation? So what we can now say is that somewhere between, it is very likely that somewhere between 65% and 73% of all Americans, not the sample, but all Americans, think that their finances are going to go up next year. And when we say it's likely, this is what it means right here. 95% confidence. Any questions on this idea? Any questions? And again, we'll get into the calculation a little bit, but I want you to understand the idea of what's going on. So now the question is, what does it mean to be 95% confident that your results are correct? That it's somewhere in between those numbers. And I like to use Gallup because Gallup is in the business of doing surveys and coming up with these intervals. Okay, that's what they do. So they do it every single day, right? At least every week. Now, sometimes the interval they get is going to actually contain the whole population proportion, which is what they're hoping to do, right? 69% was their best guess. 65 to 73 is their interval. Somewhere between 0 and 100% is what Americans really think. But what we can say is that 95% of the times that they publish a paper like this, they publish an article, they're going to get it right. They're going to actually have that population proportion in the interval that they claim to have it in. And 5%, they're going to blow it. Any questions on that idea? Any questions? Is that clear so far? Okay, I want to write some stuff down because I'm going to leave it. Once I leave it, it's hard to get back to it. Put it here. So we had 69%. And then our interval went from 65% to 73% because the margin of error was 4%. Okay, and that was a 95% confidence interval. A lot of percents here. That's just the way it goes. Okay, so once we have that, what we want to do is we want to really interpret what all this means mathematically. And remember, this is a math course. So let me pop this in just 1 second. And let me go to reshare. Okay, so now I can start drawing. That's why I wanted to have this. Okay, so what we can do is we saw that the sampling distribution is approximately normal because NP and NQ are bigger than 5. Okay, we needed that, right? So then what we can do is we can do a little sketch. So we have this normal distribution. That was a pretty good one of my better normal curves. So there's our normal curve. We know from the central limit theorem that our best guess for the mean of the normal distribution is going to be 0.69. Whoa, way too big. Try that one more time. That's better. Any questions on that? So what we want to do is we want to say, well, what is a 95% confidence interval? So we want to say that if the mean had been 0.69, okay, or if the proportion had been 0.69, and we did another sample of 1,017 people, okay, or many samples of 1,017 people, then we want to bound this. So let me do a little brushing now. I want to bound this so that this area is 0.95. Any questions on the idea of what we want to do? Any questions? So anyone know why we're using 0.95? Yeah, kind of comes from the empirical rule. And there's kind of an interesting history about this. The history came from, I forgot what presidential election, but it was in the 30s. So it might have been Roosevelt. It was one of the 30s presidents, where, you know how there's always a few polling places that try and say who's going to become president, right, in the election? Any guess on who got it right? Any thoughts? Okay, the answer is Gallup. So Gallup got it right, and the New York Times, along with Gallup, published it. You know how it is, the next day after the election's over, and they got who won. They went, haha, we're right, everyone else is a loser. All the rest of them pretty much went out of business, and everyone listened to Gallup and the New York Times and said, we're going to use 95% because that's a lot better than doing some other like small percent chance of being right. Because you want to be pretty confident. And 95% is what the New York Times pretty much said is what we're going to do, and everyone listened. Any questions on that? Okay, so now we know, and I'm not going to do all the little calculations, but from the central limit theorem, we know how to calculate the standard deviation of a sampling distribution, square root of p times 1 minus p all over n. So that'd be 0.69 times 0.31 divided by 1,017. Take a big square root, and you get some number. Basically, you multiply that by 2. Okay. A little better approximation is about 1.96. And that'll tell you what the margin of error is. And you can come up with these numbers that we got before, which is 0.73. So now let me write them out. And I'll answer in a second, but I just want to finish writing. So we get 0.73 and 0.65. And those are going to be our boundaries. And the question is, it is always 1.96 to 2 decimal places of accuracy? The answer is yes. Because remember, this is a normal distribution. Normal distributions don't change, right? They are what they are. Okay, so that's how many standard deviations. That's what you multiply the number of standard deviations are. But honestly, damn it, you're never going to do that anyway. Because you're going to use, any guess? This guy. You're going to use a calculator and it's going to do it for us. Okay, but I want you to understand what's going on, and this is what's going on, is a confidence interval comes from the central limit theorem. And the central limit theorem tells you have a normal distribution, and when you have a normal distribution, you can say, all right, well, what is that 95%? It's about 2 standard deviations on either side, right? Or 1.96 on either side, and that's what's going on. The calculations itself, we're going to let the black box do for us. Any questions at all on this idea? Okay, let's do it. Okay, we need one more thing before we do it, and that is we need a little calculation. Maybe you guys can tell me, what is 69% of 1,017? Because that's the number of people who said, yes, my finances are going to get better. I don't know what I'd say about myself because my finances are fine. Next year they'll be fine because I'm a saver. Okay, 701.73. So one of the things, Tammy and Najee and Joy, that you have to remember is you always have to round. Okay, if you don't round, your calculator is going to yell at you. So you have to, so let me write 702 of 1017. And let's calculate. And the interesting thing is Gallup never gets it quite right. So we'll see. Maybe I haven't actually calculated this. We'll find out if they get it right or not. So we got to do a reshare again. And I want to show you how to do this. And let's go and reshare. Go to the calculator. Okay. By the way, it's so much better when I have this double screen and I can grab all the different things. Remember last week I was struggling? So I was doing it from my little laptop at home because last week we had like 5 feet of snow. Well, this last weekend we had another 4 feet. Those of you who are in Tahoe, you know, we are pounded. And we're supposed to get more coming up. So it's white here. Any of you from Tahoe? No? No? Yeah, it is so white. Okay, so what I'm going to do, I'm going to clear everything. And again, I strongly recommend, as you're watching the webinar, participate and follow along with your calculator. Your calculator is going to look a little different, possibly, because there's like a bunch of models of the TI. But it will be able to do this. If not, you need a different calculator. But if you have a TI, 83 or 84 or Inspire, any of those will work just fine. Okay, you could also do it with my spreadsheet program, but that won't work on the test. So what I'm going to do is I'm going to hit Stat. This Stat button, I'm thinking, we have used the Stat button before. It is the most important button of the whole course, which shouldn't be surprising because this is a statistics course. Yeah, we used one var, now we're going to use something different. We're going to go to Tests. So if you go over to, and now what we're going to do is we are going to scroll down until you get to, still getting there, 1 prop z int. So 1, because we have 1 survey question, right? Are your finances going to go up? 1 population, that's it. Okay. Prop, any guess on why prop? It's nothing to do with movie sets. What's prop stand for? Any thoughts? It's really important, actually. Not seeing, I'll type in at once. Proposition's a good try. Proportion. Yeah, that's for proportion. It stands for proportion because we have a yes or no question, and yes or no questions involve proportions. Any questions on that? Z, because we found out NP and NQ are bigger than 5, so we can use the normal distribution, and Z stands for the normal distribution. And int, because we're doing a confidence interval. I just want to let you know, there are a lot of things to scroll down, and you can keep going. You see all this stuff? This is the rest of the class. So we're only halfway through about, and for the next half, we're going to go through all of these, just about all of them. And that's the whole plan. We're going to do confidence intervals. We're going to do tests also. Any questions at all on this? Okay, that's usually the hardest part, actually, is to decide which of the intervals we want. And when I say hardest part, I really mean hardest part of the final exam and even the midterm. So I hit enter. So again, X, that's the number of people who said yes. It was 702. I hit enter on that. N was 1017. I hit enter. C level is the confidence level, and that is 0.95. And then I hit calculate. Okay. By the way, is that what Gallup got? Right? About 66% to 72%. It's close, but not quite. They were actually 65 to 73. So with our calculations, the margin of error is more like 3%. Okay, Gallup said 4%. What I've found in my practice, I've been doing this for a lot of years using Gallup, is they tend to be extra conservative. Okay, they tend to be extra conservative. So we can say, now let's go back and let me just write these in. So I'm going to do the actual numbers, which is 0.66 to 0.72. And then I'm going to start typing a lot. And by the way, get used to writing a lot. Just a big warning for the assignment that's due. The assignment doesn't read you writing full sentences. So there's going to be some multiple choice on which of the full sentences is correct. I recommend not reading the multiple choice answers until you've written out what it should be and then see which one matches you. Because on the midterm, you got to write it out. So that's my recommendation for doing the assignments. For the discussion post, you got to write it out, and it's not a computer grading you, it's me. So I'll be able to let you know whether it's right or not. But I recommend keeping a journal and always writing out the what I'm about to write, the kind of stuff I'm about to write. So let me go to New Share. Let's go back to Paint 3D. Let me go to text. And I think black for this, since I'm just writing a bunch of stuff. Okay, so let me show you how we start with. A lot of people have trouble with this, so pay attention. With 95% confidence, we can conclude that the population proportion of all Americans. Notice that we're not referring to the sample, we're referring to the population. So you want to emphasize that. Who think that their finances will be better next year. Is between 0.66, and that is, by the way, 66%, and 0.72, and that is 72%. It's a lot of words. There's no way of saying it really, really short. The other way you could say it is with 95% confidence, we can conclude that between 66% and 72% of all Americans think that their finances will be better next year. Okay, notice the word all. That's essential here. Any questions at all on this example? Okay, I think I want to write down one more thing. I want to write down a question I might ask on a test, because that's important so you know how to deal with it. So the question is, what can you conclude? And the answer is, with 95% confidence, we can conclude that the population proportion of all Americans who think that their finances will be better next year is between 66% and 72%. Any questions on this idea? Any of you three confused? I know we have fewer people than usual. I have a feeling some of you might be a little burnt out from the project yesterday that you dealt with over the weekend. That sometimes does it. Okay, then I want to answer another question. Okay, and the other question is the following. What does it mean to be 95% confident? Sometimes that means interpret the confidence level. I guess I should have put a question mark. Let me do that just to make it right. See if I can make it look good. There we go. Okay, so now this is going to be a little harder. Remember, this is kind of thinking about them in the business of making confidence intervals. So let me write down. Get ready to write a lot, and I recommend you writing it also. Don't just watch. So what that says is that we can think about, again, many, many studies. If many studies are conducted with 1017 in the sample, then each of these studies will result in its own, that's right, unique confidence interval. Okay, so if we asked another 1,017 people, we'll get a different confidence interval. And then we could ask a different group of 1,017, right? There's billions and billions of different groups of 1,017 you could ask. Okay, so this is all in theory, and that's what makes this hard, is you're just theoretically saying, if you think about all the different groups of 1,017 that you could ask, then each time you're going to get a different confidence interval. 95% of these intervals will contain the population proportion of all Americans who think that their finances will be better next year. You can think about 95% of the time that you create confidence intervals, you can have a confidence interval that contains the population mean. That's what you're hoping to do. So you can think about 95% of the time you'll be successful, and then 5% you won't. Any questions on this idea? Was my promise right? There's a lot of writing. Yeah, get used to it. By the way, that's not going to change in this class. Okay? There's going to be a lot of writing. I try to give you a model so you know what to do. Okay, let's do another example now. Let me, it takes a minute to pop up an example. I got to erase everything here. Let me know, speak now, or it gets erased. Yeah, there's no easy, quick way. You could try, and maybe you'll teach me how to do it, but there really isn't. So yeah, there's got to be a lot of writing. Okay, so now let us do another one. Even the question's going to have a lot of writing. Okay. So you're interested in estimating the mean amount of time that LTCC students spend on campus on days that they do go to campus. Okay. I know none of you are ever, most of you are never going to this campus, but you could still ask the question. Based on prior knowledge, you know the standard deviation for all students is 1 point. You know what, I think I'm not going to do this one actually, because I'm looking at time. If I do that one, I'm going to confuse you. I want a different one. Let's do this one because it will be faster. Similar though. And it's also more realistic. Okay. So you want to estimate the amount of chocolate Americans eat per year. Any of you eat chocolate? Maybe none of you like chocolate. Okay. All right, you survey 64 randomly selected Americans. Find the average 12 pounds of chocolate consumed per year. Their standard deviation was 2.8 pounds. Assume the distribution of chocolate consumption is normal. Let's find a confidence interval. All right, this one is a little different because there's some tweaks to it. So first thing, I'm going to write some stuff down because we're going to go to our calculator in a moment. So we have n is 64, right? We know our average was x bar is 12, and their standard deviation, that's s, is 2.8. Okay? So one thing that's a little confusing here is that when you look at the central limit theorem, in order to find the standard deviation, in order to think about the standard deviation of the sampling distribution, yeah, as Tammy said, you need to have sigma. So what is our best guess for sigma? Not a trick question, by the way. 2.8. Okay, that's our best guess. But like everything in life, when you're just making a guess, that gives you more error. Do you agree? So there is some very, very tough mathematics that I'm not even going to pretend like I'm going to tell you how to do it, that says that we need to change the normal distribution to handle this error. So it turned out that they used to use the normal distribution, and there was this guy, okay, named Fisher, actually, who said, wait a minute, when we do this, we're not getting the confidence interval to contain the population mean 95% of the time. We're actually getting it less. We're not as accurate as we want to be. So, of course, he was a mathematician, but he had another job. His other job was beer tasting. And what he realized is that when he did samples of beer, he wasn't getting the population mean 95% of the time because he wanted to get that. He was a little bit worse than that. So he actually came up with a new distribution. And he was, again, he also was a math teacher, professor, I believe. And he named it after his students. And he called it the students' t-distribution. So we're going to be remembering t-distribution. And it turns out, I'm going to sketch it a little bit. Let's do it that way. It looks kind of like that. Now, what does that kind of look like? Yeah, it's not that far off from being normal. It's a tweak from being normal. But with the t-distribution, it's more accurate. And you want to be more accurate. You don't want to have extra error that you shouldn't have. So we're going to go to the calculator now, and we're going to find a confidence interval. So let's do that. And as I mentioned, the rest of the course is dealing with all of these menu items. So I'm going to go to Stat. I'm going to go to Tests. And I'm going to get a t-interval. So again, t for the fact that this is called the student's t-distribution, and interval because we're doing a confidence interval. Any questions so far? Okay, z-interval is if you happen to know the population distribution, the population standard deviation, but you never do. So it's really not used much. T-interval is much more important. So I'm going to get an enter. It gives you a choice, data or stats. Data is when you have data to type in. Stats is when you've been given statistics. We've been giving statistics, so I'm going to use statistics. So I'm going to enter on statistics. It asks you for X bar. X bar was 12. SX, that's the standard deviation. That was 2.8. And then N was 64. By the way, we'll get to that in a bit, actually, sorry. We're going to use the 95% level. That's standard. Okay, and by the way, use the 95% when you can. If you need to cheap out, sometimes you'll go to a 90%, but then note that you're going to be wrong twice as often. So you get with a 90%, what you'll get is you'll get a narrower interval, which is good, right? But you'll be wrong twice as often. So it's a trade-off. Okay, sometimes a 95% confidence interval is useless. So for example, if I said I'm 95% confident that the average height of Americans is somewhere between 12 inches and 200 inches, what's the problem with that? Yeah, of course it is. You haven't told anyone anything they didn't already know. Does that make sense? So sometimes you need to decide to have less confidence to be able to have a narrower interval that is more useful. So the more confidence you get, the wider the interval. So you could do a 99.99999% confidence, but your interval is going to be so wide it'll be useless. Okay, so I got to calculate. And there it is, about 11.3 to 12.7. Any questions on that? All right, so far so good? All right, so now what I can do is I can interpret it. So let's do that. Yeah, let's go purple. With 95% confidence. I think this is a little too small. Let's go a little bigger. With 95% confidence, we can conclude that the population mean amount of chocolate Americans eat each year is between 11.3 pounds and 12.7. Any questions on that? Any questions? Not too bad so far? Why mean instead of proportion? That's a really good question. What's the survey question? What are you going to ask this American? Yeah, you're going to ask the American, how much chocolate did you eat last year? Do you see that? Not do you like chocolate? That's not what you're going to ask. The data is based on how much chocolate you ate, because we have an average of 12 pounds. An average doesn't get into do you like chocolate? An average is how much chocolate. So that's why it's a population mean. Very important. I will take off lots of points if you get those confused. So one of the key things for the rest of this class is to be able to look at the question and say, is this a yes/no question? Or is this a question about means? And that's a big, big deal. Any other questions? Okay, let's do one more example. Sorry about that. And I'm gonna have you put in the chat box some data. Okay, let's find out the ages of, let's say, the 5 people who you are closest to. Okay, and I want you to type that in the chat box, and as you're doing that, I want to put that in the calculator. So just a minute. Let me go to statistics. I'm going to edit. I'm going to clear out L1. And now I'm going to start typing them in. 79, 68, 47, 30, 31. Remember the 5 people you're closest to. How old they are, not how tall they are. So hopefully you all know that in years, not in days. So Joy, you want to put them in? And we still have Ozzy here. 7, 8, 10, 15, one more, and 3. Children, for sure. Okay. Maybe I'm going to put in some of mine too, because we need enough data to get this interesting, and I don't see Ozzy putting it in. It'd be nice if you did, though. So I'll put mine in because we need some data. So let's go to 55, 24, 42, 80, and I need one more, and that would be 50. Actually, it's not 50, it's 61. Wait, it's not 61. Let me get this straight. 58. Okay, so now what we're going to do is we're going to find a confidence interval for the population mean age of people that were I don't know, LTCC faculty and students are closest to. So I'm going to get a stat. I'm going to go to tests. Still going to be a t-interval. We do not know the population standard deviation. That's for sure. We just have a bunch of data. Okay, it's not stats, it's data this time. So I get a data and hit enter. You'll notice now it asks for different stuff. So the list is L1 because that's where I put it in. Second one. Freak is 1. I'll do a 95% confidence interval again. And I'll go calculate. And there we have it. Okay? We can be 95% confident that the population mean age of people that faculty and students are closest to is between 22 and 52 years old. Notice a couple things. One is that this is a pretty wide spread. If I instead went to tests and I did a t-interval, which is, by the way, number 8 is a faster way. And I went to 90%. And I calculated it. Now the spread is between 25 and 49. So notice it's a more narrow spread, more useful. Okay, still pretty spread out. How do you get a smaller spread? What could we do? You could do a lower percent, but what if you don't want to give that one up? We don't want to be worse than 90% accurate. There's really only one way to have it all. Remember, having it all means you're very confident and you have a small spread, and that's exactly a larger sample size. So we want to have a larger sample size. And if you had a larger sample size, then you would get a smaller spread. The other thing is, notice n is 15. So we have to assume that everything is normally distributed, which is probably wrong. Assumptions are bad, by the way. That means you're just like giving it up and pretending that you're right when you're wrong. So n equals 15 is a really bad idea. Why am I doing an n equals 15? Any thought? Okay, because it just takes too much time. Too much resources to do over 30. But if you had over 30, we don't have to make the assumption. All right, so now let me do the next type of question. So let me go ahead and do me share. And let us select. Okay, suppose you want to construct a 92% confidence interval for the mean number of spam emails that come in daily per account. And you want a margin of error of no more than plus or minus 0.8 spam emails. If you know that the standard deviation of spam emails is 14, how many email accounts must you monitor? Any questions on that idea? Any questions? This is asking not for a confidence interval. What's it asking for? How to start, but in particular, the sample size. Okay, this is a find n question. In fact, let me type that in because that's really important. Find n. Okay, and one thing that's really important is we're looking at a confidence interval, right? CI for confidence interval, for a mean. Okay, notice it's a mean because the survey question is how many spam emails did you get? It's not yes, it's I got 72 spam emails or something like that. Any questions on that? So what we need, and I'm not going to do all the math for it, but we do have, there's going to be a formula that we need that's really important. So when you have a question to find n for a mean, n is going to be the following. It's z times sigma over e. Squared. Okay, so you don't need to memorize it, but here's a strong recommendation: get this guy in a note card for the midterm. You get a note card. This is one you definitely want on it. So z is going to come from the normal distribution. Sigma is a standard deviation, and e is a margin of error. The plus or minus doesn't matter because we're squaring it, so you can do the positive. Any questions so far? Okay, so I'm going to write down the stuff that's easy, the stuff we know without any issue. We know that sigma, I'll just spell it out because it's too hard to type Greek letters just with paint, is equal to 14. And we know that E is equal to 0.8. What do we need to find now? Yeah, we need to find Z. Well, Z, it comes from the normal distribution. So I got to draw a picture. So there's the picture, you're used to that. We want a 95% confidence interval. 92% confidence interval. So that is 0.92. Any questions on that so far? Okay, what we don't know and we need to know is we need to find out what that area is. What is that area? See if you can tell me what that area is. If we know the middle area is 0.92, what is the left area? Yeah, not 0.08, it's actually 0.04. Yeah, 0.04. Because the total area outside of the 0.92 is 0.08 or 8%, but the left is only half of that, which is 4%. So we get 0.04. And we want Z. Well, if you know the area to the left, then how do we find the value Z? We've done this before a couple chapters ago. See if you can tell me. Yeah, we're going to do IMV norm, not norm IMV, but IMV norm, but you get the idea. Okay, so let's do a new share. Let's go back to the calculator. So I'm going to go ahead, clear what I had. And if you remember, I go to distribution, IMV norm. Area is 0.04. This is the standard normal, so the mean is 0 and the standard deviation is 1. And I hit enter. and enter again. And you get negative 1.75 about. So just a note, let me write this out. New share. So now we can say Z is equal to 1.75. Why do I not worry about the negative? I can just ignore the negative and I can get away with it. No, that Z is not an area. Z can be negative. Z is negative. It has to do with the square. We're going to square it in the formula, so you can ignore negatives. So now you just put it in a calculator. Now we just type in n is equal to Z, which is 1.75, times sigma, which was 14, divided by E, which was 0.8, and then we square it. Tell me what you get. And I'll try also. So what do you get? Hopefully you can all get this. This isn't supposed to be hard, by the way. You don't even need a fancy calculator. I actually just typed it in the URL bar of my computer, and I got it. Yeah. Now, does that mean we need to survey 937.89 inboxes? What's wrong with that? No, it's not a percent. It's not a percent. What's wrong with it is you can't survey 0.89. You should always round up. This is the one case where you always round up, not down. You just always round up. So 938. Any questions on that? Okay, I want to just give you a note because we don't have time to do like full examples. This is for the means. For a proportion, there's a different formula, obviously, because there is no sigma. Okay, so you got to have a different formula. So there are actually two formulas for proportions. So let me write those out. I'm going to get rid of what I've got here. But the problems are done in similar ways. So if you're doing proportions and you don't know anything, you have no information, then you just go 0.25 times Z over E squared. And by the way, if you want to do a 95% confidence interval with a 3% margin of error, that's a little more than 1,000, 1,069, I think, or 1,068, somewhere around that. And that's why you'll see Gallup doing that. They always do a little more than 1,000. And that's the reason, is if you plug this in, that's what you get. Okay. Sometimes you have an estimate or an idea what the proportion is. Like you might do a sample of, say, 50 first, get an idea of what the proportion is. If you know the proportion or have an idea of what the proportion is, then we're going to use n equals p times 1 minus p. And then the rest is the same, times z over e squared. So if you have a preliminary estimate for the proportion, that's what you use. So Tammy, the reason, you probably don't want to really know why, but the reason why it's 0.25 is that if you look at p times 1 minus p as like x times 1 minus x, it's a parabola. And the vertex of the parabola is when p is 0.5. And when you plug that in, you get 0.25. Did you really want to know? But that's the reason. And that's where the 0.25 is coming from. Yeah, I'm not going to test you on that, but you do need to have these written down on paper. You have to know when to use which. So again, these are for survey questions that are yes/no survey questions. So like the Gallup poll survey question that we did originally, that is going to be using this 0.25 times z over e squared if you don't know anything. But let's say they did it last year, and now they want to do it again this year to get a new result. Then you're going to use last year's proportion for the p. Does that make sense? And the z and the e are the same idea. Any questions at all on that? Yeah, like the discussion, can be. Any questions? Okay, we're at that mark where I kind of like to tail it off around now. But again, in the long video, you get to see examples of this. In the book, it's got examples also. So, keep this in mind. The z, how do you find the z? What do you have to draw? Yeah, a normal distribution. So you have to draw a normal distribution to find that z, and then you can use an IMB norm. And that's how you get that z. And you need a calculator for that. All right, so what I need to do now? Any guess? Yeah, secret word. And the secret word of the day is population. And the reason for that is when you're doing your interpretation, okay, of the results, you have to say the population mean is between these numbers, or the population proportion is between these numbers. So I always try and use a word that's really important. You're going to guess proportion. I thought about it, but population will emphasize a mistake a lot of people make. And that is to forget to use that word in the interpretation of the confidence interval. So I think I'm going to unshare and get into Q&A mode. Stop share, there we go. And it's a small group. Hopefully you'll be less burnt out next week. This chapter is not easy, but it's not that brutal either. This is not usually what people complain about. There's a lot of writing though. This is the part of the course where we start doing a lot of writing. Not a lot of math, a lot of writing. Okay, there's a lot of calculated work too, but mostly writing. So that's what you'll get used to. And again, look at the models. There's a few models. You learn the model for proportion, you learn the model for means, and you've got it. So any questions at all about anything? Again, this is Q&A time. You're happy to say it too. Yeah. Any questions?
Joy has one, Professor. I'll let you answer her, and then I have
one. Go. Just want to know if you got my email for the discussion arc. Yeah, Joy, I found that was really weird, actually. Not like you did something wrong, When I went to look, when I get a little, there's like a new post and it shows me, then I go find the new post. It showed your post actually. And then when I went click view it in discussion, it got erased. So I don't know what happened actually. Sorry about that. But fortunately you were able to show it to me via, and then when I went to the grading thing, it actually showed up again. So I was actually able to see it when I went to I have something you guys don't have, which is a little grading tool that shows all the posts that each student individually has in their little thing. And it showed up there. So I'm sorry if that happened. Technology is always weird sometimes. So sorry about Joy. I have no idea actually. But the good news is I was able to see your post. And then hopefully you saw my comments this morning. I wake up early. Actually, it was late for me at 5:30 in the morning. That's when I started doing your grading. I did the grading of the post first, and then I went to the projects. And I'm about a third of the way through the projects. Tomorrow, maybe I'll finish tomorrow, if not Wednesday, on grading projects. Okay, other questions? Tammy, you had one?
Yeah, on the 3x5 card that we can bring in. So I have things like or event, and then A or B equals outcome is in A or B. Can I have statements like that or only formulas?
So here's the thing about the 3x5 card. You can write anything you want on the front and back. Completely unrestricted. So
Really?
Whatever you want, you can write it, but you are limited to space.
Yep.
And there's a lot of things to write, so you'll probably run out. Yeah, so you're limited to space, but you're not limited. You write anything you want. When I email the proctor, I let them know that 3x5 index card, writing on both sides, no restrictions.
Okay, great.
Yep.
The other two questions I had were just me. I think you and I we're the only ones on here. So I had a weird thing happen on my discussion.
If you want me to stop recording, I can do that too.
Okay.
Okay, but let me say goodbye to everyone.
Yep.
For those of you watching this as an archived lecture, don't forget the secret word, and don't forget this is the time to start investigating who your proctor is going to be if you don't yet have a proctor. Don't wait till the last minute on that one, or you're going to be scrambling and then not be able to take the test. So until next week, which will be next Tuesday, unless I hear otherwise, for requests, we'll have that as the next webinar. So hopefully you understood confidence intervals.